Hello everyone, and in this lecture we are going to do Pert, Program Evaluation Review Technique. Earlier we did CPA, which is Critical Path Analysis. This is what Pert is. It's a project management technique used to manage uncertain activities of a project. It is an improved version of the CPA because in the CPA we would have to know the exact duration of each activity. In Pert, sometimes you may not know the exact duration of an activity. This is why this method is an enhancement. In order for us to use Pert, we need to look at activity times, the probability distribution for activity times to allow for variability. Now, there are three pieces of information that are required. We must know the optimistic time, which is the best case scenario. If everything goes according to plan, what is the least time it would take to complete that task? The pessimistic time is the opposite. So assuming that there are any unfavorable conditions, what is the worst off case or the most time it could possibly take to finish that task? And then there's a most likely time denoted by M, which looks as the most realistic estimate of task completion. So A is optimistic, B is pessimistic, and M is most likely time. Now, in order for us to calculate the expected time of the project, it is denoted by this formula. T equal A plus 4M plus B divided by 6. So this is the standard formula that we will use. And remember, A is optimistic time, M is most likely time, and B is pessimistic time. So this formula shows us that the expected time T equals optimistic time plus 4 multiplied by most likely time plus your pessimistic time. All of that divided by 6. We also need to calculate the variance of times. The variance of times is denoted by V equals B minus A divided by 6 squared. We will look at an example of this. Now, for a visual representation, this is what the beta distribution looks like. And we can see that if the most likely time is at the middle of the curve, the optimistic time would have to be on the left and the pessimistic time would have to be on the right. Let us compute the variance. What we have in front of us is some activities. We have A, the optimistic times, B, the most likely times for each of the activities, and B, the pessimistic time for each of these activities. Let us calculate the expected time. Given the formula that we saw in the slide before, let us compute the first expected time for A. So, expected time for activity A is equal A plus 4M. So let's look at what A plus 4M is. A is 1. 4M would be 4 multiplied by 2. So 4 multiplied by 2 gives us 8. 8 plus 1 gives us 9. Plus, our pessimistic time, which is B, equals 3. So 9 plus 3 gives us 12. We now divide 12 by 6. So 12 divided by 6 gives us 2. And that's how we calculate the expected time. So for practice, you can repeat for each activity and ensure that you are getting the result as shown by this column, the expected time column. Let's now see how do you compute the variance. The variance, as we saw in the slide earlier, is computed by this formula. Pessimistic minus optimistic divided by 6 squared. So, let's calculate the variance for activity A. Pessimistic time is 3. Variance optimistic time is A. So 3 minus 1, which is B minus A, gives us 2. 2 divided by 6 squared gives us 0.11. You can practice. It is interesting to note now that a project variance is computed by adding up or summing the variances of all the activities that are on the critical path. Let us assume for this slide that the critical path would be A, C, E, G, F. So we are assuming that the critical path of this project is A, C, E, G, F, which is shown in red. So the variance for each of those activities that are on the critical path are also highlighted in red. In order for us to compute this project's variance, all we need to do is sum or add up the individual variances of each activity that forms the critical path. So, we take each of the individual variants that form the critical path and we add them together and we get 3.11. And this is the project variance. Now, we need one more calculator. We need the project standard deviation. To calculate the standard deviation, we just find the square root of the project variance. So if the project variance is 3.11, the square root of that gives us 1.76 weeks. We now have enough information to start calculating the probability of the expected time in terms of completing the project. But we need to make two assumptions first. One, the total project completion times follow a normal probability distribution, and I'll show you the curve. And the activity times are also statistically independent. So there are no impact factors by other operations in the firm. This is the normal distribution curve. We saw this before. Standard deviation 1.76 weeks, and the expected completion time, we are assuming that it would take 15 weeks to complete this project. All right? So we also have to assume that it would take us 15 weeks to complete this project. So we're working with that assumption as well. And then we previously calculated the standard deviation, which is 1.76 weeks. Now we have enough information. Let's calculate the probability of this project to be completed on or before the 16-week deadline. So, initially, we expected the project to be completed in 15 weeks. However, as a manager, I would like to know the probability of this project to be completed on or before 16 weeks. So, how is that calculated? This is the formula. Z is equal to the due date minus the expected date of completion divided by our standard deviation that we calculated earlier. So, the due date of the project is 16 weeks. The expected date of completion is 15 weeks, which is a little earlier. So we expect to complete the project 15 weeks. However, deadline for project completion is 16 weeks. The question we are asking here is, what is the probability that this project can finish before the deadline or on the deadline? So on or before that 16-week deadline. So 16 weeks minus 15 weeks is your due date minus your expected date, and it's divided by your standard deviation. When we've computed that, you'd get your Z value of 0.57. We have one more step to complete in order to calculate the probability of the project to be completed before its due date. So, Z is the number of standard deviations the due date or target date lies from the mean or expected date. We need one tool. We need the Z table. You can find the Z table at the back of your textbook in the Appendix 1. This is statistical tables that are prepared and can be used by statisticians. In recent times, those things are also part of statistical software, so we don't have to calculate it. However, the tables are there for us to use so that we can find the value of Z. So, all you need to do is go to the table and you have to look for our Z value, which is 0.57. So, in this column, we have 0.5, but we need 0.57. So we're going to have to come across until we reach 0.07 to make 0.57. So when 0.5 matches up to read 0.57, this figure would be there for you to see. We have highlighted it. The figure is 0.71566. That is approximately 71%. So, in our previous slide, we saw that the standard deviation of Z, which is 0.57, gave us in the Z table, a probability of approximately 71.57%. This is telling us that in answering the question was asked, what is the probability of the project being completed on or before the 16-week deadline? And the answer is that we are 71.57% sure that the project can be completed on or before this 16-week deadline.